Okay, so this is going to finish up the notes that we didn't get to finish last time we were in class, because of that practice I step. So this is going to finish it up. So pay attention, fill in the rest of the notes. You're going to have a quiz on this shortly. So we started off with mean, median, and mode. Those are the measures of central tendency, which we can use to calculate reasonable prices or reasonable things for our data. So there's mean, median, mode. Mean is the average, where you add them all up and divide by however many there are. The median is the middle number, and then the mode is the most often appeared number. And so what we're going to want to do is decide when we should use mean or median. So since we don't use mode, we're going to be using mean or median. So it turns out that you use mean when all of your numbers are close together, and median when you have numbers that are far off, called outliers. So numbers that are significantly higher or lower than the rest of your data is called an outlier. And so if you have outliers, you need to use the median instead of the mean, whereas mean is when they are close together. And I'll show you examples of that. So, and then we got through the first example here on sales tax. So when assessing sales tax, it's really easy. You just multiply whatever the amount is times the tax. So just remember that you don't use the percent. You have to change it to a decimal. So here we did 7,400 times 0.085. And that gave us $629. So there'd be $629 in sales tax. Okay, so the other examples here we didn't actually get to. So what we want to do is read the problem, obviously. So this is Jason. He wants to sell his Ford SUV. He compiles the list of prices from the internet for similar cars to his. And so he's trying to figure out, what should I sell my car for? There's a bunch of different prices. So he's going to try to figure out what he should sell his car for. And so we look at the data. So we see 11,000, 9,900, 12,100, 10,500, 9,000. And so we have to decide, are all the data points relatively close together, or do we have a value that is significantly higher or lower than the rest of them? And so it turns out that these numbers are all relatively close together. So you have 11,000, 9,900, 12,100, 10,500, and 9,000. And so since they are all close together, to find a reasonable price, we're just going to use the mean. So we're going to add them all up. So if we add all these up here, we get 52,500. And then we just divide by how many there are, which is 5. And we get 10,500. And so this would be the reasonable price that he should sell his Ford SUV. And so example 3 is the same thing. All the values in example 3 are relatively close together. In that particular problem, it just says to find the mean, so you don't have to do that. I mean, you don't have to decide. It asks you what the mean is, so just find the mean. So in example 4, so here's one that's different. You have Dory, who's looking to find a classic 1967 Firebird. So she's looking at prices online, and she's trying to find, well, what's a reasonable price to pay for one? And she sees 18,000, 77,000, 22,000, 21,200, 19,000, 17,500, and 22,500. And so she calculates the mean as $28,171.43. And she's thinking to herself, 28,000, wow, that's like way more than like almost all of them. That doesn't seem like a good, representative of the data. And so maybe you noticed it, but Dory didn't. You you have an outlier. So we look at all these prices and we can see one of these is significantly larger than the rest of the data. So this is called an outlier. So you can't actually use mean, you have to use median. And so one of the things that we have to be careful with when doing median is that we do need all the numbers in numerical order first. So I'm going to put them all in numerical order. So I have So there's all the numbers in numerical order. And so once we have them in numerical order, you just select the middle number. And so you have this one matching this one matching this one matching this one, and we're left with a middle number. So in this case, it's really easy because we have an actual middle number. So our median is 21,200. So that would be a reasonable price for a 1967 Firebird. Much better than the 28,000 that you got. The one thing that we have to be aware of is that sometimes this has an odd number of numbers, so the median was really easy to find, but sometimes we have an even amount of numbers and our median falls in between two numbers. So if it falls in between two numbers, like let's say, for example, this wasn't here, so now we're doing this and we find that and let me see if I can do this without erasing any numbers. There you go. So if we have all our numbers there, and so let's say we get to this one, now we have two numbers that are in the middle. You would have to average them. You would have to add those two and then divide by 2 to find whatever number is right here in the middle. So just in case that comes up. So here's an example, number 5, where you'd find the median. Again, I'm not going to do it. You can just put them in numerical order. And then, actually, let's do this one because this one has an even number of numbers. So let's put them in order. Let's see. So we have And so there's all the numbers. And so this is an example where when we go to find the median, we see that there's 2 of them that are there. And so what we have to do is add these 2 and divide by 2 to find the number that would be in between these. And it turns out that it's 7750. And so this would be our median if it ends up in between. Number 6 is find the range, and the range is something you should be familiar with, but that's the highest number minus the lowest number. And so for this case, it would be 3,300 would be our range. Now the last part here is our last outcome. And let's see, I think this is it, yeah. And this is where we're going to make a box and whisker plot. I'm not sure if you saw this when you were in middle school, or maybe in freshman algebra, but box and whisker plot is used quite a bit, and it's on most standardized tests. But basically, a box and whisker plot organizes your data into what are called quartiles or quarters. And so you can get a lot of information from your data if you organize it into a box and whisker plot, which we'll see here. So when you have a box and whisker plot, you take your data and you're essentially going to cut it into 4 pieces. And so think of all your data as like a piece of pie, and you're just slicing it in half, and then you're slicing it in half again, and you get 4 equal slices. So here is our, let's see, there is 9 numbers here. And so the first, think of a pie or a pizza. Think of a pizza. When the pizza comes out of the oven, the first slice is going to be cutting it right down the middle. And so we're going to find our median here. And so we have 4, looks like our median is 31. And you can always tell because I can count the numbers to the right. There's 4 numbers to the right and 4 numbers to the left, so I have median. And then when you go to cut the pizza again, you're going to cut that half, those halves, into halves again. So we are essentially going to find the median of the first half and the median of the second half. So let me refresh here. So again, when we're doing this, okay, so here's our median. Now, let's sort of reset the data here, and now we're going to cut our halves into halves. So we have these 4 that I need to cut in half. So there's an even number here, so my median's going to be in between. And then on the right side, 1, 2, 3, 4, there's an even number, so my median is going to be in between these. To find those, I average the 2 numbers that are here. 17 and 21 is 38, divided by 2 is 19, so my median here is 19. And on this side, since it's 32 and 32, that one's really easy. It's just 32. And so what you do is you just draw the box part between the edges here, between your end halves there, the left half and the right half. You just draw a box between those. And then your whiskers, the box and whisker, goes out to your highest and your lowest number. And so what it does is it creates it makes your data into 4 equal parts. So let me use different colors here so you can see this. So I have one section here, one section here, one section here, and one section here. And so you'll see that my data is divided into 4 equal parts, or quarters, or what they call quartiles. And so each data, or each section of data, represents 25%, or 1/4 of my pie. Think about this. Remember, we cut our pie in half, and then we cut our halves into halves. And so if you think of a pizza, it's cut into 4 equal parts, So you have each one being 1/4 of the pie, or pizza. Okay. So now once we do that, we can answer all these questions. And so it says to find the quartiles. Well, the quartiles are just the medians that you found. So this would be the first quartile. This one right here would be the second quartile. And this one would be the third quartile. There's 3 of them. And those are the 3 medians you found. The first median was the middle, and then the other 2 medians were the middle of the middles, or the halves of the halves, I should say. And so you end up with 3 quartiles. And so example 8 says, what % of numbers are above quartile 3? So if we look at here, what numbers are above quartile 3? So I have, here's quartile 3. And so all the numbers that are above quartile 3 would be the 25%. So what percent? It's easy. It's just 25%. Okay. So now let's do an actual problem here. This one doesn't have quartiles. This one just has to find the outliers. And so the final problem here is to find the outliers. And so what you're doing is you're looking for a number that is significantly less or significantly more than the rest of your data. And I would say this one's a little tricky. I wouldn't give you a problem that's this sort of, you could go either way, but what you'll see is you have a lot of numbers sort of in this range here. I would say that my 45 would probably be an outlier, and then my 545 would be an outlier. You can argue and say that maybe just the 545 is the outlier, but that would be an example. So you would use median for this and not mean. That's all it says. So please work on the practice problems and